So if you choose to write these down, fine. If not, I have been, let's say, criticized for that in the past by maybe not students, but when they don't understand and then parents go home and say, well, he told us that we didn't have to write it down. No, it's a personal choice if you decide to write it down. I think maybe that gets lost in the translation. Okay? So if you are struggling with these or don't understand them, what might be a good idea to do?
Write them down.
Write them down. Okay? So then if you don't understand them, then, hey, I just said, you don't have to write them down. That is a choice to do that. Okay? I think perhaps we could speak for multiple staff members. That gets to be quite irritating. Just try to take the easiest way out. It's always somebody else's fault, right? Okay. What do we notice about those compounds? That's true. That's important to know. Okay. So what organic families do we see on the left two compounds? What would the organic family be? Well, alkene. That's right. Ene doesn't mean anything to me, but when we say alkene, that's what we'll be talking about. Okay? So, what is the first thing that you're going to want to do to establish naming these? Okay? So, in this case, what is your longest continuous chain? It's that, correct? Okay? And then finally, what is the last aspect you need to tell me about this? Okay? So is it 2 or 3? Okay? Because it occurs after which carbon? Okay? So now, one of the aspects that we would want to continue with that is for all alkenes, in this case, this would be your molecular formula. Okay? Do you think that's correct? Well, how many carbons do you have?
That is correct.
Okay? We've got 5 carbons. Okay? How many hydrogens? We got 3, 4, 5, 5 and 2, and 3 more. Okay? So 10. So what would happen if we were to choose possibly doing that? It's still C5H10. It's still 2-pentene. Okay? So might have to go one more. And there we go. Now what do we have? Okay? Now we've got pentene. So what this would perhaps tell you then, these two are what of each other? Because this also has C5H10. Yeah, it's an isomer. It's got the same formula, but what's different between the two? Okay? The placement of what? The double bond. That's right. Okay? So, what's difficult about this is when it comes to that of double bonds or alkenes, the amount of isomers is just a little more complex. Okay? Because on the last page of your paper, it said what? Okay, so that means you have to draw pentane first, which would be C5H12, correct? So then anything after that will still have a formula of C5H12, but what's going to be different, just like what we illustrated here. Yeah, well, true, but longest chain is a different way of saying the structure is different. Okay? This would not be the only isomer, because we've already established that these two are isomers of one another. What about if you chop one off of here, and then we could place him here? That's a trick question. Why? That is still 2-pentene. Does anyone not understand that? Okay? Or is it, I don't want to ask a question and look foolish? Maybe it's the latter of the two, but what might be more foolish? Not understanding and not asking, or not understanding and asking? Because I'm willing to bet this is one of the things that I would always say in baseball. I don't want to go up to the plate and strike out 3 times. No one wants to look like a fool. I've looked like a fool before. It happens. Okay. Then maybe go 2 for 3 the next game. Sometimes 3 for 3. And then maybe ground out twice and walk the other time. Then we're 0 for 2. Because when you walk, that means that at bat don't count. Okay? It doesn't count against your average, put it that way. Okay, so is this, I'm going to put this up here. Is that a different structure? Yes, it is. Because we've got 1, 2, 3, 4, 5. There's that. There's 2, and 3 gives you 5. 2 more is 7. 3 more is 10. So we still have C5H10. So what would this compound be called? 2-methyl-2-butene. 2-methyl-2-butene. Oh, I just repeated what you said. Okay. So then, okay. What about if we did and now what about that? That's still a trick question. That's still 2-pentene going in that direction. Okay? So we had that there, had that there. Okay? And then let's see here. There should be one more, and I think that would be here. Okay? Now we've got what? We got 3-methyl. 3-methyl-butene now. My point is there are more isomers that exist with double bonds, because not only can you put derivatives on there, but you can move the double bond. When you have to do isomers, hopefully they're alkanes, right? Because they're only single bonded. And hopefully you don't have to give all of them if it's a large number like nonane or octane or heptane. There's quite a few that would exist. Okay. Can we erase this? Okay. Now, you had alluded to the obvious earlier, that this is not straight, it is bent. Okay? Yes?
Can I see if I have that one right? I'll tell you what I have.
This one here?
Yeah.
Just tell me.
Trans 3 hexene.
So close.
3 trans hexene.
Okay, so do what you'd want to do first. Your parent chain. Okay. What organic family are we dealing with? Okay. Still an alkene. Okay. Then where is that double bond located? So let's start going from left to right, correct?
Either way.
Okay. This will give you 3 hexene. This will give you 3 hexene. Okay. This is where, so close. Okay. Because you had said that, which is not correct. Okay. Actually that. Cis 3 hexene. Okay? Because what happens is if this was to be trans 3 hexene, that means these would have to be down here, and then that would be a hydrogen over here. That would be trans 3 hexene. That's what I said. You were so close. That is correct.
What do each of these mean, cis and trans?
Okay? What I think makes the most sense is, first of all, look to see if it's not straight like this. We all would agree that this, that's hexene, correct? Okay, I thought I counted 6. Okay. Okay, we all would agree that that is hexene. So the difference between, what's the difference between them? No, second row. What's the difference?
Oh, the second one.
Yeah, no.
That one doesn't work.
Are you in the second row?
But that one don't work.
Are you in the second row? All right. Okay. This is a straight chain. This is not. You alluded to what you said, bent earlier, correct? So if it's bent like this, it's either a cis compound or a trans. Now, the reason that that is important is what we want to say is go by your hydrogens. If they're both pointing in the same direction, whether they're both pointing up or whether they're both pointing down, that is the indication in a bent structure if it is a cis compound or a trans. Now, the trans part means you're transferring all the way across. That's how I would look at it. Then your hydrogens are pointing in opposite directions like this. Okay? One is up, one is down. But if they're both oriented in the same direction, then it's this. Okay? That's more so of a biochemistry application because carboxylic acid, they go through the process of what we call hydrogenation, and they're naturally occurring in nature. When we talk about trans compounds, then those are broken down in the body, and our bodies really don't like them. Okay? Because what's going to happen is this disassociates or breaks apart in a particular manner that we really don't want to metabolize it because it's harmful to the body. That's why, and we talked about this before, I don't know if I can spell this right. Is there an E in there? No E. Okay? Okay? What? Nacho cheese, ranch, fiery, what? So the most important thing that you would look to or look at as a consumer, first of all, you're looking for your Doritos. Now you want this regular flavored nacho cheese, but then this is advertising what they put up there. 0 trans fats. Okay? So when we're talking about trans fats, it's molecules that can be traced all the way back to this idea. Okay? And for those of you who have to take biochemistry, whether here or in college, you will learn that. Okay? Not only that, but biochemistry sometimes circulates or circles around A and P at the same time. Okay? Just because of the compounds that we talk about at that level. Okay. Can we erase this? Okay? This is what trips students up. And I just like doing it for a cruel chuckle. Just for my own laughs. Just like we say, so what do we mean by this? Second row, second row. It's not that we want to pick on you people, but yeah, we kind of do. But we also want everyone to understand this. And so we're all moving in the same direction. We've been around long enough. The quicker we get started, the quicker we cover the material that I want to get done, then the rest of the time is yours. Okay, so this should be telling you something very specific. It is an alcohol. So somewhere on this compound, there has to be this. Okay? So the simplest alkane is natural gas, which is what? Methane. So then, the simplest alcohol then would be derived from methane, which you said was what? Methanol. Okay? That is the simplest alcohol. Okay? What does it mean to be an acid? Ooh. When you go to the doctor and they crack your back, you go, ooh. Right? Does anyone go to the chiropractor at all? Sometimes, yeah. Walk in because the old vertebral column looks like that. I hope not. No, that's the movie 300 with Gerard Butler. That one character who let. Yes, he wasn't called Hunchback though.
I don't remember his name. It had a weird name.
Yeah, but that's what this reminds me of. Yeah. But see, I didn't think anybody would know that who've actually seen the movie 300.
And he couldn't raise a shield. And that's why they didn't want to fight.
Right. That is correct. Okay. So, what is your simplest acid then? How many carbons? Okay.
No, it'd be 2. Yeah.
Okay.
And then you have your OH. And
Then you have your double bond.
on top of this, that metal one. And then you got filling and hydrogens. Oh, that means you could do it with one though.
Nobody does. See, I got to make myself look smart. Okay. So, is it working? Okay. We're going to use, okay, because if we said the simplest alkene has to have how many carbons? It has to have 2. Okay. Then the simplest alkyne, and that was on your paper. And what did you call this? And you're not wrong when you put that down, but if you really understand that it's got more so of a common name, don't go to the gas supply store that has these in canisters and say, I need some ethine. Chances are they're going to say, I have no idea what you're talking about. Okay? Probably see this instead. What does that say? What is acetylene used for? It is. In other words, for those of you in the shop class, you have two canisters. Okay? This top canister is probably filled with oxygen gas. Then the other canister, about like this, is filled with acetylene. And then it's got the funny looking handle, okay? Because it has two, I don't want to say jets or hoses, okay? That goes into this nozzle. So you turn it, and then you take your striker, and then it goes poof, okay? And then it comes out as an orange flame. That's after you, now you got to go to this side and open up this valve. Then it's got the funny looking deal with the thumb. What does that thumb do? Releases more, not acetylene, oxygen, okay? That's why we call it, okay? Who's an industrialist in here? Oxygen acetylene torch. That's why we'd say, you don't say oxygen ethine torch. No one would know what you're talking about. Okay? So sometimes common names are used. Okay? So everyone would know what an oxygen acetylene torch is. So this is the common name for that. So in this case, okay, you had said this is, did we name it? Now we did, okay? So then, using your same logic, 2 is incorrect. So follow our same logic, methanoic acid. Do you talk about the, in history class, the 1920s when bootlegging was taking place? Okay. You don't want to drink this, okay? When people go through the distillation process, you do it once, you get methanol. You have to go through that process again. And then when you do that, you can drink that. You can drink ethanol. That's fine. It's when people back in the 1920s, well, you can't. You shouldn't. Let's put it that way. You shouldn't. Okay? When people would drink this, okay, through different, let's say, organic reactions inside the liver, this gets oxidized into this, and the receptor sites for that are in the eyes. And people that would drink methanol to excess, they go blind because this is being converted to that in their eyes, and it just, I suppose, burns their lenses, and then they can't see. Very, very unfortunate, but it does happen. Not anymore. At least I wouldn't be led to believe so. But again, something like that can happen. It's usually not referred to as methanoic acid. You'd probably call it formic acid. All right. So then, what is the simplest compound with an isomer? Okay. We heard propane.
No, it's butane. I was thinking all the ice.
Okay. This would be the simplest compound that has a naturally occurring isomer. Okay. In other words, you just chop one of them off and put it there. Okay. So sometimes what looks like simple is these two, but sometimes when it gets down there, it says the simplest one. Sometimes it's not. Okay. And then for those of you, again, who take this more so of an advanced class, well, we won't go into that. Okay. Any questions over that? Ring structures. Eventually we'll get into aromatics. That might be tomorrow. That will be included in your second paper. All right, so rut row. Are we on the bus? Second row. Third row. Now we're nodding our heads yes. Do we really understand? Okay, so that's all I have. The rest of the time then is yours. Catch up to you next time.